So if I would have known, if they would have told me I had to follow Calvin after lunch, I would have turned this gig down because it's very difficult to follow that guy. Typical designer, I wrote this presentation in the last 12 hours. No, just kidding, but not really. So don't expect the graphics that Calvin had. I want to start. I was not able to turn around and see through the bright lights. I want to do this one more time to know who's in the audience. If you're a designer, structural engineer, architect, landscape planner, anyone, spec writer, how many do I have? Oh, there's more of you now. You guys were lying before. That's awesome. Okay. You just wanted to hide. I get it. Very specifically, concrete subcontractors and suppliers. Okay. And how about general contractors? Okay, cool. So, I think what Stephanie said in introducing this session is where I want to go with what I'm about to tell you. And that is, let's try to figure this out amongst ourselves and keep the lawyers out of it. So, I want to come at this from the design perspective and maybe offer some advice on what I've seen over the years, on what we could potentially do as designers and maybe as an industry as a whole to help keep us out of the oak paneled room. Let's see if this works. Okay, I know who you are. I think it's very important that you know who I am and my background and how it shapes what I'm about to tell you, because this is a very, this topic is fraught with lots of different opinions. So my opinions are based upon, I've been doing structural engineering in what I would call a medium-sized firm, regional firm with national reach. We do some overseas work. I've been doing this for a while, far too long potentially, and my emphasis since the day I graduated from college has been on commercial buildings of all types and sizes, from one story to probably the biggest building I've ever done is on the order of 3 million square feet. So pretty big gambit. In addition to designing buildings, our practice, we get into a lot of dispute resolution, peer reviews, so I also tend to see drawings and specifications from a lot of different firms throughout the country. So I have I think a pretty good handle as well on what current practices are, the good, the bad, and I probably should have put the ugly up there too, because there are some ugly ones that we see. And probably most important for this presentation, I'm also the guy in my office who has the primary responsibility for risk management. So I come to this presentation with the perspective of knowing how much time it takes a designer when there's a problem, how much time you're going to lose dealing with the problem, potentially more fee dollars. If you wind up in court, your deductible's gone, whether you're at fault or not. So I have a pretty good handle on why we need to keep ourselves out of that oak paneled room. So, here's the question. Every single designer in this room right now has an answer in their head to this question. Anybody willing to say it out loud? It's the contractor's fault. Right? Just kidding. Okay. But in reality, I think this is the answer to that question, in my opinion. A lot of times, it's practically impossible to figure out why a specific crack happened. Right? Why? I jotted these items down. It took me about 10 minutes. They were the first ones that came to my mind. I'm sure there's about 100 others. Okay? I think it's worth some time going over these just to get an idea, if nothing else, in your mind that there's a whole bunch of variables, and different people control these variables on the job. Everybody who touches that job eventually has at least input into one of those bullet items, or maybe 4, or maybe 7. But any one of these things and a whole host of others that aren't on that list could lead to that concrete cracking, modulus of rupture being exceeded. There's a crack. Reinforcing type. Bonded reinforcement. PT. Fiber. Right? What type of reinforcing do I have? Reinforcing location. Do I have a member that's got bottom steel only? Bottom steel and top steel, mid-depth steel. When I talk about location, can I place that reinforcing within a reasonable tolerance that I can expect it's going to wind up in a place? I'll talk about that a little bit later. If you don't know, we're talking about wire, okay? We'll come back to that. Reinforcing amount. Am I at an area of the slab, or whatever it happens to be, where I have a decent amount of reinforcement, or am I at a spot where I'm at code minimum? So how much rebar I have, or PT, whatever I have at a certain spot, certainly impacts the level of cracking. Framing restraint. In my opinion, probably the most overlooked by designers as far as impact on cracking. If I'm at a, let's call it a plaza slab at grade, and I have basement walls all the way around, and I might have ramp slabs with walls going down to subterranean parking, those walls all provide restraint to shrinkage. In the PT world, we call that restraint to shortening. We have a name for it. But the reality is those stiff elements, maybe it's a very large architectural column. For whatever reason, I have a 3-foot by 4-foot column. That column is going to provide significant restraint to the ability of that slab to shrink, so you have a higher risk of having cracking occur at that location. So evaluating the effects of framing restraint and maybe putting some rebar in some of the hot spots is an issue. Concrete mixture characteristics. I am not talking about shrinkage comp concrete here. There's a wide variation in concrete mixtures. We did a little study in one city that we design in, and I'm not going to name the name to keep the guilty out of the presentation, but if you look at a bell curve of the shrinkage characteristics of the mixtures that were being provided by the typical suppliers in that city, about 85% of them for a specific concrete strength, let's just say it was 5,000, had pretty good shrinkage characteristics. There were another 10% that were a little marginal, and that were a couple on the far right of that bell curve that were really off the deep end. So what are we doing as designers? Are we okay that we're just going to say, give me a 5,000 pound mix? Or do I need to do something else? We'll talk about that more in a little bit. Curing method selected. Am I throwing down a curing membrane as soon as I can? Is it wet burlap that hopefully is being re-wetted from time to time? Am I fog curing? All has an impact, right? Curing execution. I'm doing everything I can. I'm putting saw cut joints in the slab. Am I getting on right after the slab is sound enough to take that machine, or am I delaying 3 hours? Does that matter? What's the throughput rate of my fogging machines? How much water am I putting into the atmosphere? Does that matter? The size of the concrete placement. As the concrete placement gets bigger and bigger and bigger, I potentially have more and more potential for restraint to shortening, right? Designer's probably not in control of that one. What's the spacing between control joints if I'm a slab on grade? Will impact potentially where I crack, how much I crack. Time between adjacent concrete placements is another good one. The first pour is going to some extent, provide restraint to the second pour that's right next to it. The first pour is still shrinking. Where on the timeline are you? Where on the timeline of that first pour vis-a-vis the second pour are you? That can have an impact on cracking as well. Formwork and reshoring cycle. Am I pulling the formwork early? We have the classic race, right? Concrete is gaining properties, but at the same time, I want to get that formwork out as quickly as I can. So where do those 2 points meet will have some impact on the stresses that concrete sections are going to see. So what I want to stress, though, is what I want to talk to you about today is the normal stuff we all do each and every day, trying to do what we can to mitigate cracking. We're not going to talk about if someone makes an obvious error, because that is probably the one time where someone is going to get the finger pointed at them and say, we know what you did wrong, right? If a designer leaves a bunch of steel out for whatever reason, I forgot to put minimum steel in that area, yeah, you're probably going to get your finger pointed at right there. Or if I'm the contractor and I forget to saw the joints in the slab on grade, pretty much we're going to know pretty quickly what happened. I don't want to talk about that stuff today, because that stuff doesn't lead to conflict, right? When those types of errors are made, generally pretty quickly you know what the cause is. I want to talk about the stuff that winds us all up in oak-paneled rooms. So, that was the prelude to the discussion. So what I want to get into is to explore the kind of cracking that we see in a typical building structure, specifically related to the stuff that gets us all into trouble all the time. I want to talk about what we as designers can do to reduce the risk of that conflict. And for those of you in the room who are also contractors who have face time with owners in maybe pre-construction reviews, or if you're doing design build work where you're actually responsible for design, some of this stuff may be important to you as well, okay? So, Calvin talked about concrete cracks. We all agreed that concrete cracks. No one dissented. So there is a whole bunch of information in no less than 7 ACI documents that I found over the last 2 weeks talking about cracking and what expectations are. Here's a pretty good one that I like from ACI 302, and I'm sure you all can read, but I think this is important, so I want to read this one to you. This guide contains recommendations for controlling random cracking caused by normal volume change. Present technology only permits a reduction in cracking, not elimination. And here's my favorite parts. Even with the best floor designs and proper construction, it is unrealistic to expect completely crack-free floors. And the most important part for everyone in this room, every owner should be advised that it is completely normal to expect some amount of cracking on every project. Think about what that means for a minute. 302 says that. There's several other documents that ACI publishes and others that have this statement in it. I think they're the same people. They wrote the same stuff, almost word for word. So anticipate this question in an oak-paneled room. You, Mr. or Miss So-and-so, did you advise the owner of the possibility of cracking as ACI recommends? It scares me. I don't know about you. But as a risk guy, I don't want that question. Just pointing it out. So, Calvin started talking about this. Communication is extremely important. It is my personal opinion that you have an obligation to communicate with the owner what the expectations are. If you don't, I think you're putting yourself at risk. Especially with new clients. If you have a client you've done 10 buildings with, and you've had that discussion and everyone kind of knows, great. But with new clients, maybe not. Surprises are the problem, right? If you have a discussion with an owner about what can be expected, and he walks out on the floor deck for the first time, goes, oh yeah, there's a crack there. I kind of expected that. You told me I'd see some of that. No problem. If you walk out with an owner who you didn't have that discussion, he looks at it and goes, oh my God, that's cracked. Something's wrong. Who did it? You know, who's going to fix it? That's a problem. Same crack. So, the one thing I would say, if you could just remember from this conversation with me today, is communication is extremely important. As a designer, there's usually a kickoff meeting with the owner on traditional design bid build jobs. Maybe you want to get that on the agenda. There's a whole bunch in our office, there's a whole bunch of things from the owner performance-wise that we like to go over. This is one of them. What's your expectation? I think that's important, especially if you get it in writing. If you are a contractor, good time to have that conversation is at a pre-construction meeting for concrete, pre-concreting meeting, because the owner is almost always there. Mr. Owner, what's your expectation? The designer told me, or the way I see the drawings, it is set up, blah, blah, blah. You want to have that discussion before the concrete's placed, because having that discussion after it's placed is usually going to be a problem. So there's a number of opportunities along a normal project path to have that discussion, I think. These things scare me. This is why I like to have discussions with the owner. Because if I hear an owner either conveying to me in writing in an RFP or in some design standards, or if in the course of conversation I'm told I want a crack-free structure, or I want a very low maintenance structure, red flags, buzzers, and bells are going off for me everywhere, because that's code for we have a problem here. Right? We need to educate this owner because their expectations are not in line with what he or she has bought. So those early communications are very important to try to get this information out of your clients. So, what happens if you have those discussions and you realize you have an owner who may not be happy with the, let's call it the normal design construction approach? These are the things you should be discussing with the owners. And again, as a designer, I'm having these early on. As a contractor, you can be having these at a pre-concrete conference if you so choose. But to me, the first question is, what's that owner's risk profile? Floor coverings. Calvin mentioned this carpet. We probably don't care. I'm sure, 100% sure there's shrinkage crack that's under our feet. We don't care. Right? If I have a raised floor system, you probably don't care. If you're doing a floor that's in an operating room that has epoxy, high-end epoxy flooring over it, you probably do care. So what's going on top of that slab? Do I have a durability exposure? Am I doing a parking garage that's non-post-tensioned in Boston that's going to have a high chloride loading? I'd be more concerned about a crack there. I'd be less concerned if that slab was post-tension, because the cracks are going to close most likely, or most of them. So how does durability affect that issue? I've been on a bunch of ACI committees for a long time. We've tried to define what exposed to fumes has meant officially for about 25 years, unsuccessfully. So here's my low-tech definition. We have areas where it matters and areas where it doesn't matter. Right? If I have a wall, let's say I have a architecturally exposed wall in the lobby of this hotel, and if I have cracking, it probably matters to somebody. But if I have that same cracking in a wall of a mechanical room in the basement, it probably doesn't matter at all. Do I have a risk with my finishes? Do I have a slab that's going to support terrazzo? Because then I have read-through risk. Now that is an architectural problem, where it's an architectural risk, right? Because we know that cracks generally tend to read through that type of finish. So my whole point is we should be having this discussion. We should be assessing what the risk of that crack is. If that crack is going to cause someone pain, we may need to react to it. If it doesn't cause anyone any pain, we don't need to do anything else. Because the reality is if it causes someone pain, we're spending, as Calvin said earlier, we're spending money to fix that. And by fix it, I mean in the design early on. We're increasing the design budget to do something special. So, with that said, the usual sources of conflict that we see, elevated slabs, two types generally, elevated slabs, reinforced concrete. Most people in the ACI world will call this a suspended slab, one-way slab, two-way slab, with or without beams, drop panels, all that good stuff. And we're designing that to ACI 318. And for the designers in the room, we all know by heart, since we were born, that the minimum steel in that slab is 0.0018 times the gross concrete area of whatever section you're looking at for a slab, right? So there's a code specified minimum amount of steel that has to go into that slab regardless. Slabs on metal deck are not governed by 318. They're governed by the Steel Deck Institute. There's a little document out called the Standard for Composite Steel Floor Deck Slabs, SDIC, if you really want to look into it. And the amount of steel I have to put in that slab is about half of what 318 requires. And the reason for that is they're expecting that the composite metal deck is providing some amount of reinforcing for shrinkage. Slabs on ground. Most of the time, little qualifier, also not governed by 318. So there's a couple of different techniques out there. PCA's got one, WRI has another one, but again, generally speaking, the amount of reinforcing in those slabs is pretty low. In that condition, we're counting on the control joints to force cracking to occur where we want it to occur, where we find it to be acceptable. And then, of course, we have walls. Long runs of walls are susceptible in the same way, designed to 318. For the rest of this presentation, I'm not going to talk about walls too much because they're very similar to the other items I'm going to speak to. But these are the items that we see where most owners wind up objecting to cracks that they find. So let's take them one by one briefly. Elevated slabs. And I understand that there's all different kinds and definitions of cracking. Calvin had them all up in his slides, but when it comes down to it, for my sake, you can group them into three pieces. You have early age cracking due to volume change. Most of it's shrinkage. You can also get temperature. Not temperature change due to ambient temperature, but temperature gradient caused by the concrete curing. Right? Generally occurs in random locations, and in our experience, in our office, is the most common cause for conflict because it happens early, everyone's still on the job site, and everyone sees it. Depending upon the formwork removal process, you could kind of have a little delayed reaction. You could have shrinkage stresses that don't quite get you to the modulus of rupture, right? Everything's still formed, and you have concrete shrinkage stresses that are high, but not at the modulus of rupture, so no crack. As soon as you pull the formwork, now the slab supports its own weight. So you have a superposition of the shrinkage stresses and the flexural stresses now due to the slab's own weight, and that could be enough to send you over modulus of rupture, and you'll get cracking. And it will look like it's flexural cracking because it's going to occur at the spots of maximum flexural stress. But most likely what it is shrinkage-driven cracking that happens to occur after you pull the formwork because that little bit of weight, the slab now supporting itself, is driving you over the edge. We always hear that concrete is designed to crack. Most people are talking about in-service cracks, load-induced cracks. Okay, those happen years out if a lot of the structures we designed are never even loaded to the loads they're designed for. So I don't think I've ever seen in my entire career a load-induced crack that's been a cause of conflict. So that stuff is generally not what we're talking about. Here's the ACI stuff again. 302. The minimum amount of steel required by the building code, which is your 0.0018, right? May not be sufficient to meet the owner's expectations for crack width. This is what ACI is telling you. Be prepared to confront that in an oak-paneled room. Steel Deck Institute, this is what they tell you about a slab on metal deck. It's unrealistic to expect crack-free floors. Every owner should be advised. And I truncated it off because I ran out of room, but that's exactly the same statement out of 302 that you saw earlier. Exactly the same. So this is normal. So what do we do if normal isn't acceptable? So this is the same chart you saw before, except as a designer, I can kind of change the stuff in red if I have to. Okay? But when I do that, I'm spending the owner's money. We're back to that again. So we better be clear with the owner that we're spending his or her money. What can I do? I can change the reinforcing type. If I have a really bad situation, I have bonded reinforcement, I can add PT and close those cracks up. If I'm a slab on metal deck and I just have wire, I may want to add fiber in addition to it. Reinforcing location. If I have a one-way slab with just bottom steel, you may want to think about adding another layer of top steel near the top surface. Reinforcing location, if I have a slab on metal deck and it's only reinforced with wire, do I really want the wire 1 inch from the top? Because if you do, that's probably a little bit different than what normal specs say. Reinforcing amounts, I'm certainly in control of that as a designer. I can add more at a cost to somebody. Framing restraint. I cannot change the architecture of the building most of the time, so I can't reduce the restraint, but what I can do is I could add reinforcing across the plane that I'm expecting is going to crack as a result. So I could do that. Concrete mixture characteristics. This was the comment I had before, okay? Again, I don't want any part of shrinkage compensating concrete on most of my projects because it's very expensive. But if I can specify a minimum shrinkage value that eliminates that far 10% of the right side of the bell curve we talked about before, you're probably in a much better state than if you were totally silent on that issue. We're seeing this a lot more, by the way, in the drawings and specs that we review. A lot of designers across the country are starting to specify shrinkage characteristics in their mixture designs. Curing method selected, I really don't like to do it, but from time to time, you can dictate to a contractor, you must fog cure. Right? That's possible. I could do that. So I have a realm of things that I can do. I want to make sure I'm speaking with the owner before I do it, though, because the concrete budget just went up if I put any of these in, right? We all agree? Slabs on ground. Very similar discussion. The only thing that's different about slabs on ground is now I have this special thing called curling, which is really shrinkage again. But what's different about a slab on ground? Well, let's go here first. Same type of thing. 302 is telling you. It's even giving you a percentage. If you have that discussion with the owner, well, how much random cracking can I expect? Well, 302 kind of says about this. It's a starting point. What can I do in a slab on grade? Same type of things. Reinforcing type. Same discussion as we had before. Location. Reinforcing amounts, although be careful with reinforcing amounts, because in a slab on grade, you can put enough rebar in to cause a problem. So I would suggest that you read 302 very, very carefully before you increase the amount of rebar you put in the slab on grade. Concrete mixture we talked about. Curing. The big thing with slabs on ground, control joint spacing, right? Probably the most effective thing, in my opinion. I can tighten up that control joint spacing and reduce the risk of cracking. Again, it all costs money. All right. I've given you my perspective, fair and honestly. I have a couple more slides. I want to warn you, I am now getting on my soapbox. Okay? For things that really annoy me, and I want to bring to everyone's attention. And these are the things that, in the interest of all of us in the room, if we can work together and eliminate this stuff I'm about to show you, I think we'll all be better off. So, communicate, we've talked about over and over again. You've heard it from Calvin, you've heard it from me. I haven't seen any of my future presenters' presentations. I guarantee you pretty well that you're going to hear it again and again and again and again. As designers, I implore everyone in the room, don't embed conflict within your drawings. We see it time and time again when we're brought in to help fix a situation. Be fair and be reasonable in the drawings and specs you're putting together. The next slide is going to show you a specific example of one of about 8 things that I'm talking about, okay? So, this first paragraph I took out of a master specification just 2 nights ago that I would be willing to bet, without knowing who the designers are in the room, most of you are probably using this master specification that is used throughout our industry. And it has this requirement under concrete repair for fixing cracks in formed concrete surfaces. There is a similar statement that addresses repairing unformed concrete surfaces that I did not put in this presentation because if I went over it with you, I would get really, really angry. But if you're using that master specification without altering it in your office, I suggest each of you go back to your office whenever you get back there and look at your master specs. The very last few pages of your master specification of 3300 or where repairs are found, and there's going to be a section on repairing formed surfaces and repairing unformed surfaces. So let's start with this one. We're repairing formed surfaces, and they talk about all this stuff, and we are repairing cracks in excess of 0.01 inches. So put in your mind a picture of, I have a 2-way concrete slab. Maybe it has drop panels, maybe it doesn't. And the contractor is pulling the formwork off the bottom of that slab soffit. Okay? Everybody got that picture? So I'm taking the formwork off a formed surface. What does he or she see when you pull that form off? This specification applies, right? Everybody agree? So, if I see a little crack on the bottom of that slab, that specification tells me it must be repaired. There's no, differentiation between a crack that maybe is a through crack that may let water in from above. It's just a crack. Every crack that you see must be repaired by this specification. 0.01 inches, for context, is less than 1/64 of an inch. So how do you even figure out that you have a crack that's 1/64 of an inch? I've never seen anyone on a job site with a tape measure hanging off their belt that can measure to a 1/64 of an inch. Maybe some of you have. I have not. That number is equivalent, because I checked with a micrometer, if you take 2 pieces of standard 8.5 by 11 printer paper and put them together, you'll get a number that is slightly larger than 0.01 inches. Just for context. Okay? So, as designers, do we really need this? You're just setting us all up. All of us. Designers, contractors, everybody. Put yourself in the contractor's shoes. How do you deal with that on bid day? From what I've seen, you have one of 2 choices. So first of all, let me just say, as designers, what are we trying to do? Protect our owners. So we think we're doing well by putting this in the spec, right? We're protecting our owner. Something bad happens, it's going to get repaired. What's going to happen on bid day 85% of the time? Concrete contractor is going to exclude that from his bid because he's got no way to quantify it. He's going to submit it to the general contractor, who's also going to exclude it from their bid because they don't want that liability either. So now, unless someone's reviewing that bid, and there's 1,000 line items, exclusions in that bid, right? There's a good chance that you've nullified all protection you have for the owner because it's been excluded entirely. All crack repair is gone. That happens most of the time. For the contractors that don't exclude it, and those are the folks who aren't reading the specs when they're bidding jobs, you know who you are. It's going to show up after there's a problem. Someone's going to read the spec and say, you owed me this. And then we all really have a problem, right? So my I'm imploring all of you, please, to go back to your offices. Look at what your specs say in regard to cracking. Just be fair and reasonable. Right? Do I really need all this stuff? What's my owner's risk profile for cracking? Maybe it varies across the job site, but I don't think you need that most of the time. Right? That's all I had, folks. I'm open for questions.